At the very edge of our solar system, far beyond the familiar planets and the distant glow of the sun, lies a shadowy realm where the rules of space seem to bend. This is the Oort Cloud, a vast and mysterious frontier filled with objects so strange they defy everything we thought we knew. Some move in ways that shouldn't be possible. Others vanish without a trace. A few might even be visitors from another star. Today, we're diving into 25 of the most bizarre objects lurking in this cosmic wilderness, each one a puzzle waiting to be solved. From a possible alien probe disguised as space junk to a comet so dark it's nearly invisible, these discoveries are rewriting the story of our solar system. So buckle up, because what lies ahead will challenge your imagination and leave you questioning just how much we truly understand about the universe. And trust me, by the end of this journey, you'll never look at the night sky the same way again. Now, let's turn our attention to the first object on our list, one that sent shockwaves through the scientific community. Meet Oumuamua, the first known visitor from interstellar space. Discovered in 2017, this bizarre, cigar-shaped object streaked through our solar system at an angle no native comet or asteroid could match. Its trajectory alone was enough to raise eyebrows, but what really left astronomers scratching their heads was its behavior. Unlike typical space rocks, Oumuamua didn't just coast along. It accelerated as it moved away from the sun, as if something were pushing it. Theories exploded about what this mysterious traveler could be. Some suggested it might be a fragment of a Pluto-like world, torn from its home system and sent drifting through the cosmos. Others raised an even more tantalizing possibility. Could Oumuamua be artificial? Its unusual shape, long and narrow, unlike any natural object we've seen, fueled speculation that it might be a derelict spacecraft or even an alien probe. While most scientists lean toward natural explanations, the truth is, we may never know for sure. By the time telescopes could get a closer look, Oumuamua was already speeding out of reach, leaving behind more questions than answers. What makes this interstellar wanderer even more puzzling is its path. It didn't swing around the sun in a smooth curve like a comet. Instead, it zipped through at an odd angle, as if it had been flung into our solar system by some distant cosmic event. This strange trajectory, combined with its unexpected acceleration, forced astronomers to rethink what they knew about how objects move through space. Oumuamua didn't just challenge our understanding, it revealed how much we still have to learn about the universe beyond our doorstep. And with that, we move on to our next cosmic oddity, one that's even harder to spot but just as mysterious. Now, let's venture into the shadows of the Oort Cloud, where an invisible enigma lurks: the dark hydrogen iceberg. Unlike Oumuamua, this object doesn't reflect light or leave a visible trail. In fact, it's nearly impossible to spot with telescopes, and that's exactly what makes it so intriguing. Picture a massive chunk of frozen hydrogen, colder than the darkest depths of space, drifting silently through the outer reaches of our solar system. Because hydrogen ice doesn't interact with light the way rock or metal does, this iceberg would be virtually undetectable except for one telltale clue: gravity. Scientists suspect objects like this could explain strange gravitational tugs observed in the Oort Cloud. When the paths of known comets or asteroids don't quite match predictions, a hidden mass like a dark hydrogen iceberg might be the culprit. But how does something like this form? Imagine a pocket of molecular hydrogen gas left over from the birth of the solar system, chilling in the void until it freezes solid. Over billions of years, these icy fragments could clump together, growing into colossal, invisible structures. And without the warmth of the sun to melt them, they could survive for eons, drifting like ghosts through the cosmic abyss. What's even wilder is how these icebergs might move. The Oort Cloud is a vast, chaotic realm where the gentle pull of the sun competes with the gravitational whispers of passing stars. A dark hydrogen iceberg could be nudged into a new orbit by a distant star's gravity, or even flung inward toward the planets. If one ever ventured close enough, it might briefly reveal itself, not by sight, but by the way it bends the light of stars behind it or tugs on nearby objects. Until then, these elusive giants remain one of space's best-kept secrets, reminding us that the most fascinating discoveries might be the ones we can't even see. Up next, we'll turn our gaze to a different kind of mystery, one that could rewrite our solar system's map. Could there be a hidden planet lurking in the Oort Cloud? The clues are mounting and the hunt is on. Now, let's shift our focus to a mystery that could reshape our understanding of the solar system, the hunt for Planet X. This isn't just another space rock. We're talking about a potential giant lurking in the frigid outskirts of the Oort Cloud with enough gravity to tug on everything around it. The idea of a hidden ninth planet isn't new, but the evidence is stacking up in ways that have scientists both excited and skeptical. The clues start with the strange orbits of distant objects in the Kuiper Belt and Oort Cloud. Some of these icy bodies follow paths that seem to cluster together, as if something massive is herding them. That's where Planet X comes in. Astronomers calculate that a world roughly 5 to 10 times the mass of Earth, orbiting far beyond Neptune, could explain these odd trajectories. Its gravity would act like an invisible hand, nudging smaller objects into peculiar alignments over millions of years. But finding this elusive planet is no easy task. Its predicted orbit is so vast that a single trip around the Sun could take between 10,000 and 20,000 years. That means it's incredibly faint and moves painfully slowly across the sky. Telescopes like Subaru in Hawaii and upcoming missions like the Vera C. Rubin Observatory are scanning the heavens for any trace of it. Yet, despite years of searching, Planet X remains hypothetical, fueling debates about whether it's real or if another explanation, like a swarm of smaller objects, could account for the anomalies. The controversy adds to the intrigue. Some researchers argue the gravitational patterns could be statistical flukes, while others insist the data points to a genuine planetary heavyweight. If Planet X does exist, it could be a rogue world captured by the Sun's gravity or a remnant of the solar system's chaotic early days. Either way, its discovery would rewrite textbooks and force us to rethink how our cosmic neighborhood formed. Up next, we'll take a look at a pair of comets locked in an eerie celestial dance, proof that the Oort Cloud holds even more surprises. Now, let's turn our attention to something truly mesmerizing, a celestial waltz happening in the depths of the Oort Cloud. Meet the binary Comet Duo, two icy wanderers locked in a slow, gravitational embrace as they journey through space together. This isn't just a chance encounter. These comets share an orbit, circling each other while also hurtling around the Sun, a rare phenomenon that offers a glimpse into the solar system's violent past. What makes this pair so special is their synchronized dance. Most comets travel solo, but these two stick together, bound by gravity in a delicate balance. Their shared path suggests they might be remnants of a single, larger body that shattered long ago, either torn apart by a collision or ripped into pieces by the gravitational pull of a passing star. Either way, their existence hints at the chaos that once ruled the early solar system, when objects routinely crashed, merged, or were flung into deep space. Scientists study these binary comets like cosmic time capsules. Their composition, movement, and even the way they interact reveal clues about the conditions that shaped them billions of years ago. For instance, their orbits are often unstable, meaning they could eventually drift apart or collide again, echoing the turbulent processes that built the planets. Some researchers even speculate that similar pairs might have been common in the solar system's infancy, only to be scattered or destroyed over time. The discovery of this duo challenges our assumptions about how comets form and survive in the Oort Cloud. It's a reminder that even in the coldest, darkest reaches of space, there's dynamic activity, and sometimes celestial bodies find companionship in the void. Coming up, we'll uncover an object that blurs the line between natural and artificial, a piece of space debris that sparked wild theories about its origins. Stay tuned. Now, let's shift gears to an object that had astronomers scratching their heads not just because of what it was, but because of what it might have been. Meet 2020 SO, a peculiar visitor that blurred the line between natural space rock and something far more intriguing. When it was first spotted in September 2020, scientists assumed it was just another asteroid. But as they tracked its path, something didn't add up. This object was moving slower than a typical asteroid, and its orbit was eerily similar to Earth. That's when researchers realized 2020 SO wasn't a random space rock at all. It was likely a piece of human-made debris, possibly a spent rocket booster from the 1966 Surveyor 2 mission to the Moon. But here's where things get wild. Before its true identity was confirmed, some theorists speculated it could be something even stranger, an alien probe. Why the extraterrestrial buzz? For starters, 2020 SO trajectory seemed almost too precise, as if it were guided rather than drifting. Its low density and unusual brightness also fueled speculation. Could it be a relic of advanced technology, either ours or someone else's? While the most plausible explanation points to human spaceflight history, the mystery highlights how little we truly know about the objects drifting near our planet. What makes 2020 so fascinating isn't just its origin story, it's the questions it raises. How many other asteroids out there might actually be forgotten fragments of human exploration? And if we can mistake our own debris for natural objects, could we also overlook something truly alien? For a brief moment, this unassuming piece of space junk became a canvas for our deepest cosmic curiosities. Up next, we'll explore a pair of objects that stand out for their striking color, two of the reddest bodies ever found in the Oort Cloud. What gives them their bizarre hue? The answer might lie in chemistry older than the solar system itself. Now, let's turn our attention to a pair of cosmic oddballs that stand out in the darkest reaches of space, not for their size or speed, but for their striking color. Meet the twin ultra-red objects, two of the most vividly crimson bodies ever spotted in the Oort Cloud. These distant wanderers aren't just red, they're ultra-red, a shade so deep it defies typical explanations. What gives them this bizarre hue? Scientists believe their surfaces are coated in complex organic compounds, possibly tholins, the same molecules that give Pluto and Saturn's moon Titan their reddish tints. But here's the twist. These objects are far older and more pristine than anything in the inner solar system. Their ruddy surfaces might be frozen relics of chemistry that predates the sun itself, a snapshot of the building blocks that eventually formed planets. The origins of these twins are just as mysterious as their color. One theory suggests they were born in the same icy nursery, a pocket of the early solar system where carbon-rich molecules clumped together under extreme cold. Another idea posits they're refugees from another star system, carrying alien chemistry into our cosmic backyard. Either way, their redness isn't just a curiosity, it's a clue. The deeper the red, the more complex the organic molecules, hinting at environments where the ingredients for life could have simmered for billions of years. What's truly mind-bending is how rare these objects are. Most Oort Cloud bodies are dull and gray, battered by eons of cosmic radiation, but these twins, they're like time capsules, their vibrant surfaces untouched by the chaos of the inner solar system. Studying them could rewrite what we know about the dawn of organic chemistry and whether the seeds of life might be hiding in the frozen dark. Up next, we'll examine an object that seems to defy physics itself, a so-called empty asteroid with a density so low it might just be a hollow shell. Is it debris from an ancient collision or something even stranger? Now, let's shift our gaze to something that seems to defy logic. An asteroid so light it might as well be a cosmic ghost. Meet the so-called empty asteroid, a baffling object in the Oort Cloud with a density so low, scientists suspect it could be hollow. Imagine a space rock so porous that if you could hold it, it might feel like a fragile shell barely holding itself together. What makes this object so eerily lightweight? One leading theory suggests it's the remnant of a shattered interstellar traveler, a fragment from a catastrophic collision that left behind only a skeletal frame. Another idea proposes it's a rubble pile, a loose collection of icy debris held together by weak gravity, like a snowball that's mostly empty space. Either way, its existence challenges our understanding of how solid objects form in the depths of space. The mystery deepens when we consider how something this fragile could survive for billions of years. Most asteroids are dense, rocky, or icy bodies, but this one seems to float through the Oort Cloud like a cosmic bubble. Some researchers speculate it might be coated in an ultra-dark material that shields it from radiation, while others wonder if it's riddled with hidden caverns, making it more void than substance. What's truly fascinating is what this asteroid could tell us about the violent history of the solar system. If it's a relic of an ancient collision, it might preserve clues about the chaotic era when planets were still forming. Or if it's an interstellar castaway, it could carry secrets from another star entirely. Either way, this empty asteroid is anything but. It's a puzzle waiting to be solved. Coming up, we'll uncover an object with a speed that defies explanation, a hypervelocity exile racing through the Oort Cloud as if something or someone flung it with unimaginable force. Now let's turn our attention to an object that seems to have been fired like a cosmic bullet, the Hypervelocity Exile. This rogue rock isn't just moving fast, it's racing through the Oort Cloud at speeds so extreme they defy easy explanation. Picture a boulder hurled from the edge of our solar system, as if some unseen force gave it a violent shove into the void. What could launch an object with such incredible velocity? One compelling theory points to a close encounter with another star. Billions of years ago, a passing star might have swung too close to our solar system, its gravity slingshotting this rock into oblivion. Another possibility, the invisible tug of a hidden black hole lurking somewhere in the darkness, could have flung it outward like a pebble from a slingshot. But here's the real puzzle. This exile isn't just speeding away. Its trajectory suggests it wasn't born in the Oort Cloud at all. Instead, it might have originated much closer to the Sun, only to be violently ejected by some ancient cataclysm. That raises an even bigger question: what kind of event could have given it such a kick? Was it a collision with another massive object, or the gravitational chaos of a young, unstable solar system? What makes this exile so fascinating is what it could reveal about the forces shaping our cosmic neighborhood. If it was indeed launched by a passing star, studying its path might help us map forgotten stellar visitors from the distant past. Or if a black hole is to blame, it could hint at unseen monsters hiding in the darkness beyond Pluto. Up next, we'll examine a comet with a bizarre composition, one that shouldn't exist according to everything we know about the early solar system. Now let's dive into something truly puzzling, a comet that defies expectations in the most unexpected way. Meet the carbon monoxide snowball, a cosmic oddball with a composition so strange, it's rewriting what we thought we knew about comets. Most comets are like dirty snowballs packed with water ice and dust, but this one, it's practically gushing carbon monoxide, a gas that shouldn't be this abundant in a comet from the Oort Cloud. Think of it like opening a freezer and finding a can of soda that's somehow still fizzy after billions of years. It just doesn't add up. Scientists expected comets this far out to be dominated by water ice, since temperatures in the Oort Cloud are cold enough to freeze almost everything. Yet here's this comet loaded with carbon monoxide, a molecule that usually requires even colder conditions to stick around. So how did it end up with so much of it? One theory suggests it formed in an unusually frigid pocket of the early solar system, a place so cold that carbon monoxide could freeze solid alongside water. Another idea, maybe it was born much closer to the Sun where carbon monoxide was more common and then got flung outward by a planetary shuffle. But here's the real kicker, this comet's bizarre makeup challenges our entire understanding of the early solar system's temperature. If carbon monoxide was this abundant, it means some regions were far colder than we ever imagined, or that chemical processes we don't yet understand were at play. It's like finding a snowman in the desert. It forces us to rethink the environment that created it. What's next? Keep watching, because we're about to uncover two objects locked in a cosmic dance, a pair with orbits so similar they're practically twins. Now let's turn our attention to a cosmic duo that seems to move in perfect sync, the so-called tagged pair. These two objects don't just share the same neighborhood in the Oort Cloud. They follow orbits so eerily similar, it's as if they're tied together by an invisible thread. What makes this pair so fascinating isn't just their coordination, it's the story their orbits tell. When astronomers spotted them, they noticed something unusual. Their paths around the Sun were nearly identical, down to the smallest details. This isn't just a coincidence, it's a clue that these two were once part of something much bigger. Imagine a cookie crumbling into two perfectly matched pieces. That's the kind of split we're talking about here. So how did they end up this way? One possibility is a violent collision. A larger body, perhaps a proto-comet or even a minor planet, could have been shattered by a high-speed impact, sending these two fragments spiraling away on nearly the same trajectory. But there's another, even more dramatic explanation: a passing star. Billions of years ago, another star might have wandered too close to our solar system, its gravity stretching and tearing apart this original object, leaving behind these two survivors locked in their mirrored dance. The tagged pair doesn't just give us a glimpse into the chaos of the early solar system, it also raises new questions. Why haven't their orbits drifted apart over time? What kept them so perfectly aligned? Some researchers think they might still be subtly influencing each other, their faint gravitational tug keeping them in sync. Others speculate there could be even more fragments out there, hiding in the darkness. Up next, we'll investigate an object that seems to defy the rules of our solar system entirely, a meteorite with a composition unlike anything we've seen before. Now, let's shift our gaze to something truly out of this world, the Mirror World meteor. This isn't just another space rock. When scientists analyzed its composition, they found something shocking. Its isotopic ratios don't match anything in our solar system. It's as if this meteorite came from a completely different cosmic recipe book. So what does that mean? Isotopes are like fingerprints for elements. They tell us where and how something formed. If this meteorite's isotopes don't align with anything we've seen here, it's a strong hint that it wasn't born in our solar system. Instead, it might be a fragment from a parallel protoplanetary disk, a sibling to the cloud of gas and dust that birthed our planets, but one that took a wildly different path. Imagine two chefs using the same ingredients but ending up with entirely different dishes. That's the kind of divergence we're talking about. How did it get here? One theory suggests it was flung our way during the chaotic early days of the solar system, when nearby protoplanetary disks could have interacted or even collided. Another idea is that it's a rare survivor from a long-vanished system, drifting through interstellar space until our sun's gravity caught it. Either way, this meteorite is a tangible piece of a place we've never seen, a cosmic message in a bottle. What's even more intriguing is what it implies. If this object really is from another disk, it means our solar system isn't the only one with its unique chemical signature. There could be countless others, each with their own strange blends of elements. Some might even harbor materials or compounds we've never encountered. Up next, we'll examine an object that spins so slowly. It's like a cosmic tortoise defying everything we know about how celestial bodies move. Now, let's turn our attention to a celestial oddity that moves at a pace that baffles astronomers, the slow-spinning mystery. Most objects in space, whether planets, asteroids, or comets, rotate at speeds that fit neatly into our models of celestial mechanics. But this one, it's practically dragging its feet. Imagine a spinning top gradually winding down, except this object's rotation is so sluggish. It challenges everything we know about how things move in space. Normally, rotation speeds are influenced by factors like an object's size, composition, and the forces acting on it. But this slow spinner defies expectations, taking far longer to complete a single turn than similar objects. So what's causing this cosmic lethargy? One possibility is internal friction. If the object has a loose, rubble-like structure, its own shifting material could be acting like a brake, sapping its rotational energy over time. Picture a bag of marbles tumbling in slow motion. The constant collisions inside would gradually slow things down. Another tantalizing theory suggests an unseen companion might be to blame. Just as the moon's gravity creates tides on Earth, a hidden moon or binary partner could be exerting tidal forces on this object, slowing its spin to a crawl. If that's the case, spotting this elusive companion would be a major breakthrough, but so far, it's remained invisible to our telescopes. What makes this mystery even more intriguing is what it tells us about the diversity of objects lurking in the Oort Cloud. Not everything out there follows the rules we're used to. Some worlds march to the beat of their own drum, and this slow spinner is a perfect example. Coming up next, we'll uncover an object that behaves like a comet but hides in plain sight, a so-called dark comet with secrets of its own. Now, let's pull back the curtain on one of the Oort Cloud's most enigmatic visitors, the so-called dark comet. At first glance, it checks all the boxes for a typical comet, an elongated orbit that swings it close to the sun before hurling it back into the depths of space. But here's the twist: where most comets announce themselves with brilliant tails of gas and dust, this one stays eerily silent, leaving almost no trace in the night sky. So what's hiding its light? One leading theory points to an ultra-dark surface, possibly coated in organic compounds or carbon-rich material that absorbs sunlight instead of reflecting it. Think of it like cosmic charcoal, so pitch black that even our most powerful telescopes struggle to pick it up against the void of space. But there's another possibility. Instead of spewing the usual mix of water vapor and dust, this comet might be venting something far sneakier, invisible gases like nitrogen. Without the reflective glow of ice particles, its tail would be practically undetectable, like a stealthy shadow slipping through the solar system. This isn't just a cosmic oddity, it's a game changer. If dark comets are more common than we realize, they could rewrite the rules of how we track and study these icy wanderers. After all, how many more might be lurking unseen, their secrets hidden in plain sight? Up next, we'll crack open a cosmic onion, an object with layers that tell a violent story of collisions and rebirth in the frozen reaches of the Oort Cloud. Now let's peel back the layers of one of the Oort Cloud's most intriguing mysteries, the cosmic onion. This bizarre object isn't just a simple chunk of ice or rock. Instead, it's built like a celestial Russian nesting doll, with alternating shells of frozen water and dense stone wrapped around each other. What could create such a strange structure? The answer lies in chaos. Picture this: long ago, a massive collision shattered a larger body into fragments. Over time, gravity pulled these pieces back together, but instead of forming a solid mass, they stacked in layers like a snowball rolling through debris, picking up alternating bands of material. Each shell tells a story of violence and rebirth, a frozen record of the Oort Cloud's turbulent past. But here's where it gets even weirder. Some scientists suggest this onion-like layering might not just be from random crashes. It could be the result of repeated close encounters with other objects, each gravitational tug stripping away outer layers and leaving behind a new shell. Imagine a cosmic sculptor chiseling away at this body over millions of years, leaving behind a masterpiece of ice and stone. Why does this matter? Because objects like this could be time capsules, preserving clues about how the outer solar system evolved. If we could study one up close, its layers might reveal secrets about ancient collisions, the chemistry of the early Oort Cloud, and even how planets like Pluto formed. Next up, we'll meet a true cosmic outlaw, an object that doesn't just drift through the Oort Cloud but has broken free entirely, wandering the void between stars. Now, let's turn our attention to one of the most solitary wanderers in the cosmos, the unbound nomad. Unlike the other objects we've explored, this rogue traveler isn't just drifting through the Oort Cloud. It's completely untethered from any star, roaming the vast emptiness between galaxies. Imagine a cosmic castaway flung so far from home that it no longer belongs to any solar system. How does an object end up like this? The most likely explanation is a violent ejection. Picture a young planetary system, still chaotic and unstable. A close encounter with a passing star or the gravitational kick from a massive planet could send a smaller object hurtling outward at incredible speed. If it's fast enough, it breaks free entirely, escaping the pull of its parent star and setting off into the void. Some of these nomads might even be remnants of failed planets, shattered long ago and sent adrift. But what are they made of? Without a star to warm them, these objects are frozen relics, likely coated in layers of ancient ice and dust. Some could be rich in organic compounds, preserved in the deep cold of interstellar space. Others might be dense chunks of metal and rock, the stripped-down cores of what were once larger bodies. The chilling truth is, we don't know for sure, because spotting something so dark and distant is nearly impossible with current technology. Yet, their existence raises fascinating questions. Could these nomads carry the building blocks of life from one star system to another? Might they even outnumber the stars themselves, silently drifting through the darkness? Every discovery of a rogue object forces us to rethink just how crowded or lonely the universe really is. Up next, we'll encounter a pair of objects so ghostly, they're almost invisible, the Oort Cloud's elusive twins. Now let's shift our gaze to something even more elusive, the ghostly twins of the Oort Cloud. These two objects are so faint, they're like cosmic phantoms, barely leaving a trace in the darkness. Imagine ice so pure, so flawless, that it reflects almost no light at all. That's what makes these twins nearly invisible to our telescopes, hiding in plain sight at the edge of our solar system. What could create such pristine surfaces? One theory suggests they're ancient relics, untouched by the chaos of collisions or the heat of the sun. Over billions of years, their icy exteriors may have remained undisturbed, forming layers so smooth and clear that light simply passes through them instead of bouncing back. Another possibility is that they're coated in exotic ices like nitrogen or methane frost, which absorb or scatter light in unusual ways. Detecting these twins is a monumental challenge. Most telescopes rely on reflected sunlight to spot distant objects, but when something reflects almost nothing, it's like searching for a shadow in the dark. Only the most sensitive instruments, like the James Webb Space Telescope, might have a chance at glimpsing them if they happen to pass in front of a distant star, casting the faintest of silhouettes. Their existence hints at a hidden population of nearly invisible objects drifting through the Oort Cloud. If there are more like them, our current census of the solar system's outer reaches could be missing countless ghostly wanderers. And that raises a tantalizing question. What else is out there, lurking just beyond our ability to see? Coming up next, we'll explore a mystery that ties the Oort Cloud to one of history's most explosive cosmic events, the Tunguska connection. Now, let's turn our attention to a mystery that bridges the past and present, the Tunguska event. In 1908, a massive explosion flattened over 800 square miles of Siberian forest near the Tunguska River. The blast was so powerful it knocked people off their feet hundreds of miles away, yet no crater was ever found. For over a century, scientists have debated what could have caused such devastation without leaving a trace. One leading theory points to a small comet or asteroid exploding in the atmosphere. But here's where it gets fascinating. Some researchers suggest the culprit might have been an object like those drifting in the Oort Cloud today. Imagine a chunk of icy debris, rich in volatile materials like methane or carbon monoxide, hurtling toward Earth. As it entered the atmosphere, the intense heat and pressure could have caused it to vaporize entirely in a blinding flash, releasing energy equivalent to hundreds of atomic bombs without ever hitting the ground. Could a similar object still be lurking in the Oort Cloud? Astronomers have identified icy bodies with unstable compositions that, if nudged toward the inner solar system, might behave just like the Tunguska impactor. The scary part, these objects are nearly invisible until they're dangerously close. Unlike rocky asteroids, which reflect sunlight more easily, dark, icy fragments could slip past our detection systems until it's too late. The Tunguska event serves as a stark reminder that the Oort Cloud isn't just a curiosity, it's a reservoir of potential hazards. While the odds of another such impact are low, the consequences could be catastrophic. That's why scientists are racing to improve our ability to spot these stealthy wanderers before they get too close. Because if history has taught us anything, it's that the universe has a way of keeping us on our toes. Up next, we'll uncover something truly dazzling, a tiny world with a diamond heart forged in the fires of a long-dead planet. Now, let's journey into the depths of space to uncover something truly extraordinary, a tiny world with a heart of diamonds. Imagine a small, unassuming dwarf planet or asteroid drifting silently through the Oort Cloud. On the outside, it might look like any other icy rock, but hidden beneath its surface lies a treasure forged in the most extreme conditions imaginable. Scientists speculate that some of these distant objects could contain cores rich in diamonds, created under crushing pressures inside the hearts of ancient protoplanets. These protoplanets, which once roamed the early solar system, were massive enough to generate the kind of heat and pressure that turns carbon into diamonds. But when these worlds collided or were torn apart by gravitational forces, fragments of their diamond-rich cores could have been flung into the outer reaches of the solar system, eventually finding their way into the Oort Cloud. What makes this idea even more fascinating is that these diamond cores wouldn't be like the gemstones we mine on Earth. Instead, they'd likely exist in a strange, ultra-dense form, possibly mixed with other exotic materials. Some researchers even suggest that these diamond cores could be surrounded by layers of ice or rock, acting like cosmic time capsules preserving the violent history of our solar system's youth. Could we ever mine these distant diamond worlds? While it's a thrilling thought, the reality is that reaching the Oort Cloud remains a monumental challenge. But studying such objects, even from afar, could reveal secrets about how planets form and what happens to their remnants over billions of years. As we marvel at the idea of diamond-filled worlds drifting in the darkness, it's a reminder that the universe holds wonders beyond our wildest imagination. And speaking of wonders, our next mystery takes us even deeper into the Oort Cloud's icy archives, a pristine comet carrying untouched material from the dawn of the solar system. But before we leave the idea of cosmic treasures behind, let's turn our attention to something even more extraordinary, a frozen messenger from the dawn of time itself. Deep in the Oort Cloud's shadowy outskirts, there may lurk comets so pristine, so untouched by the chaos of the solar system, that they're essentially time capsules from its birth. These ancient wanderers, often called dynamically new comets, have spent billions of years in the deep freeze of interstellar space, far from the sun's warmth or the gravitational tug of planets. Unlike comets that have swung close to the sun and lost their volatile ices, these relics remain in nearly the same state as when they first formed. That means they could hold the original ingredients of the solar system: water, organic molecules, even probiotic compounds, exactly as they were over 4.5 billion years ago. When one of these comets finally drifts inward, astronomers get a front-row seat to history. Its tail, glowing with vaporizing ices, isn't just a spectacle, it's a chemical fingerprint of the solar system's infancy. Some scientists believe these comets might carry clues about how water and the building blocks of life arrived on Earth. Others speculate they could reveal why our solar system looks the way it does, with gas giants in the outer reaches and rocky worlds closer in. The most exciting part, we might not have to wait long to study one up close. Missions like the European Space Agency's Comet Interceptor are designed to lurk in space, ready to race toward such a pristine comet the moment one is spotted. Imagine the discoveries waiting in that primordial ice, stories written in chemistry, waiting to be decoded. As we ponder these icy time travelers, it's humbling to realize that some of them may have witnessed the solar system's first moments. And if we're lucky, they might just share their secrets with us. Now, let's shift gears to something even more enigmatic, a signal from the Oort Cloud that sparked whispers of something unnatural. Now, let's venture into one of the most tantalizing mysteries of the Oort Cloud, a story that blurs the line between science and speculation. In recent years, astronomers have picked up strange radio signals that appear to originate from the distant reaches of the Oort Cloud. These signals, often faint and erratic, have sparked wild theories. Could they be attempts at communication from an intelligent civilization lurking in the icy darkness? The idea isn't entirely new. For decades, projects like SETI have scanned the cosmos for artificial signals, but finding one so close to home would be unprecedented. Some researchers argue these radio bursts could be natural phenomena, perhaps emissions from exotic objects like magnetized comets or interactions between solar wind and Oort Cloud debris. Others point out that the signals are so irregular and weak that they're more likely to be interference from Earth-based sources or even glitches in telescope data. Skepticism runs deep in the scientific community. Without repeatable, verifiable evidence, most astronomers dismiss the alien signal claims as wishful thinking. After all, the Oort Cloud is unimaginably vast and sparse, hardly the place you'd expect to find a bustling alien outpost. But the mystery persists, fueled by the fact that some signals still defy easy explanation. Could there be a natural process we haven't discovered yet? Or is this simply a case of cosmic static being misread? What makes this debate fascinating is how it reflects our own curiosity. The moment we detect something unexplained in space, our minds leap to the extraordinary. Whether these signals turn out to be alien tech or just another cosmic quirk, they remind us that the Oort Cloud and the universe beyond still holds secrets waiting to be unraveled. And speaking of cosmic quirks, our next object bends the very fabric of reality itself. Now, let's turn our attention to something that defies even the laws of light itself. Object 24, the gravity lens anomaly. Deep in the Oort Cloud, astronomers have spotted an object with a gravitational pull so peculiar, it warps the light passing around it like a cosmic funhouse mirror. This isn't just a slight bend, it's a distortion so pronounced that it challenges everything we know about how matter behaves in space. So what could be causing this bizarre effect? One leading theory suggests this object might be made of exotic, ultra-dense material unlike anything found in our solar system. Imagine a chunk of matter so compact that its gravity tugs at light itself, bending its path in ways that defy normal physics. Some researchers have even floated the idea that this could be a microscopic black hole, a leftover from the early universe drifting silently through the Oort Cloud. While black holes are typically thought to be massive, there's speculation that tiny, primordial ones could exist, and this might be our first potential glimpse of one. Of course, skepticism is healthy. Other explanations include a rogue, hyper-dense asteroid or a previously unknown type of celestial body with extreme gravitational properties. The challenge is that this object is so far away and faint that detailed observations are nearly impossible with current technology. Yet, the very fact that it exists opens up thrilling possibilities. If it is a microscopic black hole, it could revolutionize our understanding of dark matter or the early universe's conditions. What makes this anomaly so captivating is how it blurs the line between the known and the unknown. Whether it's an exotic material or a hidden black hole, its presence reminds us that the Oort Cloud isn't just a repository of icy leftovers. It's a frontier where the universe's strangest phenomena might be hiding in plain sight. And as we near the end of our journey, one final mystery awaits, an object that didn't just puzzle scientists, but vanished before their very eyes. But just when we thought the Oort Cloud couldn't get any stranger, we arrive at our final enigma, Object 25, the Vanishing Act. Picture this: astronomers tracking a peculiar object at the solar system's edge, only for it to suddenly disappear without a trace. No explosion, no debris, just gone. Was it a trick of the light or something far more mysterious? One leading theory suggests the object might have shattered into countless tiny fragments, too small for telescopes to detect. In the frigid depths of the Oort Cloud, collisions are rare but not impossible. A high-speed impact could have reduced this body to dust, leaving behind no visible clues. Alternatively, it might have been obscured by an unexpected cloud of cosmic dust or gas, a natural veil hiding it from our view. Then there's the more speculative angle. Could this object have been something other than a typical comet or asteroid? Some researchers wonder if it was a dense, dark body that simply drifted out of sight, or even an artificial object with the ability to cloak itself. While that idea leans into science fiction, the truth is, we don't have enough data to rule anything out. What makes this disappearance so unsettling is how it underscores the limits of our knowledge. The Oort Cloud is so vast and remote that even with our most advanced technology, objects can slip away unnoticed. Whether it's shattered, faded, or transformed, this vanishing act leaves us with more questions than answers, and a humbling reminder of how much we have yet to discover at the edge of our cosmic backyard. And with that, we've reached the end of our journey through these 25 bizarre objects. But before we go, let's take a moment to reflect on what they all mean, and what secrets might still be lurking in the darkness. Now, let's zoom out for a moment and consider the bigger picture. These 25 strange objects are just the tip of the cosmic iceberg. The Oort Cloud is thought to be home to trillions of icy bodies, most of which remain hidden in the shadows, far beyond the reach of our current telescopes. Every oddball object we've explored, from Oumuamua to the Vanishing Act, hints at an even wilder population waiting to be discovered. So why haven't we found more of them? The answer lies in the sheer distance and darkness of the Oort Cloud. These objects are incredibly faint, often reflecting less light than a piece of charcoal. Even our most powerful observatories struggle to spot them unless they venture closer to the sun or exhibit unusual activity like outgassing, but that's about to change. Enter the next generation of space and ground-based telescopes. The James Webb Space Telescope, with its infrared eyes, can peer through cosmic dust and detect the faint heat signatures of distant objects. Then there's the Vera-C, Rubin Observatory's legacy survey of space and time, or LSST, which will scan the entire southern sky repeatedly, catching subtle movements of Oort Cloud visitors over time. These tools could reveal thousands, maybe even millions of new objects, rewriting our understanding of the solar system's edge. But here's the thrilling part: every new discovery will likely bring more mysteries. If 25 objects can baffle us this much, imagine what thousands will do. We might find more interstellar interlopers, more dark comets, or even objects with compositions unlike anything in our solar system. The Oort Cloud isn't just a graveyard of ancient ice, it's a treasure chest of cosmic secrets, and we're finally getting the keys to open it. As we stand on the brink of this new era of exploration, one thing is clear: the strangeness we've uncovered so far is just the beginning. The real surprises are still out there, drifting in the dark, waiting for their moment to step into the light. Now, let's venture into one of the most tantalizing questions of all. Could life exist in the frigid depths of the Oort Cloud? It might sound like science fiction, but the idea isn't as far-fetched as you'd think. Consider extremophiles, those hardy microbes on Earth that thrive in places we once thought were uninhabitable, boiling hydrothermal vents, acidic lakes, even the frozen deserts of Antarctica. If life can cling to existence in those extreme environments, why not within the icy bodies of the Oort Cloud? Some of these objects may harbor subsurface oceans, kept liquid by residual heat or radioactive decay, creating hidden pockets where microbial life could persist. Then there's panspermia, the theory that life might hitchhike across the cosmos on comets and asteroids. The Oort Cloud, with its countless icy wanderers, could be a cosmic highway for life's building blocks. Imagine a frozen comet carrying organic molecules, or even dormant microbes, from one star system to another. If true, these distant objects might not just be relics of our solar system's past, but potential couriers of life itself. Of course, this is all speculation for now. The Oort Cloud's extreme cold and isolation make it a harsh environment, even for the toughest organisms. But as we've seen time and again, life has a way of surprising us. Every new discovery at the edge of our solar system brings us closer to answering whether we're alone or if life's reach extends far beyond what we've ever imagined. And with that, we've reached the end of our journey through the Oort Cloud's strangest secrets. But before we go, don't forget to share your thoughts. Which of these 25 objects fascinated you the most? Drop your answer in the comments below, and if you enjoyed this cosmic deep dive, hit that like button and subscribe for more mysteries from the edge of space. Until next time, keep looking up. As we wrap up this journey through the Oort Cloud's most bizarre inhabitants, one thing becomes undeniably clear: the edge of our solar system is far stranger than we ever imagined. From interstellar visitors like Oumuamua to rogue nomads drifting between galaxies, each of these 25 objects challenges what we thought we knew about space. They defy expectations, spark debates, and remind us just how much remains hidden in the cosmic shadows. Think about it, we've barely scratched the surface of this icy frontier. The Oort Cloud stretches so far, it's practically a bridge to interstellar space, yet we've only glimpsed a handful of its secrets. Every discovery raises new questions. Could there be more interstellar objects passing through unnoticed? Are there even weirder worlds lurking beyond our telescope's reach? The more we learn, the more we realize how little we truly understand. But that's the beauty of exploration. The unknown isn't something to fear. It's an invitation to keep searching, questioning, and marveling at the universe's endless surprises. So stay curious. Who knows what the next mission or breakthrough might reveal? Maybe you'll be the one to crack one of these cosmic mysteries. Before you go, let's hear your thoughts. Which of these 25 objects left you the most stunned? Was it the diamond core dwarf, the vanishing act, or something else entirely? Drop your pick in the comments below. I'd love to hear your theories. And if you enjoyed this deep dive into the solar system's weirdest corners, don't forget to like, subscribe, and hit that notification bell so you never miss a space mystery. Thanks for joining me on this adventure, and remember, the universe always has another secret waiting. Keep looking up.